This is a quick demonstration of the ImageBox3 library that allows for in-browser operation on remote and local whole slide images. ImageBox3 is a small JavaScript library built on top of GeoTIFF.js that uses HTTP range requests to extract relevant byte ranges from TIFF-based whole slide images. No server-side required. This tool is hosted at episphere.github.io/imagebox3, and this URL will also be available in the description if you'd like to follow along. All you need to use ImageBox3 is a locator in the form of a URL to a remote whole slide image or a local file. If you'd like to try out ImageBox3, feel free to click on any of the demo links and the tool should work just as well. So yeah, we have the viewer on the left here, which is built using OpenSea Dragon and a plugin built on top of GeoTIFF.js, and we can see ImageBox3 in action on the right. Everything I do in this demo is happening completely within the confines of my web browser, completely on my machine. There is no data that is being exchanged to any server-side service whatsoever. So yeah, once I have the locator loaded in, I can see the image, and now I can operate on it just as if it was locally available to me. So if I move the green square to a different region, we see a different patch being extracted. The parameters on the right define what the patch shows, what it looks like, and how big or small it needs to be. So for example, if I changed the X or the Y coordinates, we see horizontal and vertical movement accordingly. In the same fashion, we have the width, height, and the resolution. The resolution corresponds to the size of the tile as it gets returned, and the width and height correspond to the size of the patch in the image that we want to extract. The interplay between these is what defines how much fidelity the patch should contain, and that in turn determines what image in the image pyramid needs to be retrieved. And that is exactly the secret sauce. Despite this image being multiple hundreds of megabytes or potentially even gigabytes in size, we never really have to load it entirely in memory. We only load in the region that we care about, and that is how HTTP range requests allow us to operate on such large data, such high resolution data, without needing extensive computational resources. And just to show that in action, I can change the width and the height and the resolution, and we see that the patch returned is of much higher fidelity. That would be the same as if I zoomed in. We see the tiles loading in, and this operation is exactly how you would expect a server-side tile serving service to function, but everything is happening completely in my browser here. Our argument is that this makes digital pathology analytics as a whole much fairer in the sense of the acronym, much more findable, accessible, interoperable, and reusable than it otherwise would be. And to prove that, we have a copy URL button here. If I click on it, the URL of the tool as it exists right now is copied. If I were to paste it elsewhere, the same image is loaded in, and we should see the same patch being extracted. And this URL I can share with anyone in the world. As long as they have access to the image, the patch should be visible to them immediately. In that sense, this is much more reusable than a server-side service would be, where they would need to have access to not just the data, but the tool as well, to the computational resources underlying the tool as well. Therefore, we believe the web is a means of verifying digital pathology analytics, and ImageBox3 is the first step in getting there. Just to also prove that this service can work from just about any data source, I can load in an image from the Genomic Data Commons. This is a TCGA whole slide, and as the URL suggests, this is being loaded in straight from a data commons, and we should see the operation happen just the same. The file loading might be slower because the GDC is not optimized for file transfer, but just the fact that it is available via a URL means that it is operable in this environment, just like any other image would be. While the image loads in, I'd also like to mention the code for ImageBox3 is completely open source on GitHub. The link at the top here should take you to our GitHub repository where the code exists. The issues page is also on GitHub. If you have any problems using the tool, please feel free to raise issues. There's a documentation for the library, the functions, and a description of how to use them. There's a manuscript preprint on archive that we hope to publish soon. And the patch extraction component works just like it did before, now that the image is loaded in. The green square is a little smaller. Let me make it larger so we see it. Oops. Yeah. And the patch extraction works exactly the same. And just to also complete the conversation, I can show a local file being operated upon. And if anything, this will be even faster because there are no HTTP requests, even though the operation is exactly the same. We retrieve only the region of the image that we are interested in. So yeah, this is ImageBox3. Please feel free to raise issues or ask questions if you have any concerns using the tool. It is freely available to anyone who wants to try it out, not just in the form of the web tool, but also as the JavaScript library. It's available on NPM and on GitHub. We hope this is useful in verifying your digital pathology workflows. Thank you so much.